Okay, so I'm going to assume that if you're watching this video, it is because you have seen properties of the definite integral, and you have this in your notebook somewhere, all the properties of the definite integral that we talked about in that screencast, and you worked out those questions with me, and you talked about average value of a function. That's an important idea. And you went to the worksheet and you tried the worksheet questions, and now you're here and you're like, what do we do now? So I want to work out some of these with you so that you can have a sense of what the properties of the definite integral are. You do need to speak intelligently about those as time goes by. So what if we take the function f of x and then multiply it by 4? Well, that takes all of the heights of all of the rectangles and makes them 4 times as large. So this is the same as 4 times the integral from 1 to 4 of f of x dx. That's 4 times 7, and that's 28. Similarly, if you have some function g and subtract some function f and then take the area, that's the same as taking the area under g and subtracting the area under f. This almost makes sense. So that's 2 minus 7, that's negative 5. Similarly here, the 8 comes out as it did in the first example. And then the 7 comes out as it did in the first example. And so what is this? This is 8 times 7 minus 7 times 2. That's 42. And there's this. So this is going to be the negative of the integral from 1 to 2 of f of x dx. We are not given the integral from 1 to 2 of f of x dx. We are given the integral from 1 to 4, right? And we're given the integral from 2 to 4. So we're told that the big blue area is 7, and this green area, that's 5. Well, if the big blue area is 7 and the green area is 5, then we know that this area is 2, that the integral from 1 to 2 of f of x dx is 2. And that means if the integral from 1 to 2 of f of x dx is 2, then this answer is negative 2. These are the sorts of things that calculus instructors expect you to be able to do. Can we find areas? Sure we can. The integral from 0 to 2, that's this area. It happens to be a rectangle and a quarter circle. The rectangle is 2 times 3. The quarter circle is 1/4 pi r squared. I hope that's not too bad. Then the integral from 1 to 3, well, the integral from 1 to 3 is a rectangle with a semicircle on top. The rectangle is base times height. The semicircle is 1/2 pi r squared. Nothing fancy there. And so hopefully you're going to be able to figure out the area, the integral from 0 to 4 of f of x dx, because that's just this area. Oh gosh, that's ugly. That's just this area. And that appears to be a rectangle, a trapezoid, and a semicircle. So the rectangle is easy. The trapezoid, that's half the height times the sum of the bases. Well, this base is 3, and this base is half of 3, because that's 0. 3, half of 3, and then the semicircle is exactly what it was before. So this is 9 halves times a half is 9/4. And that's 9, that's 36/4, so that's 45/4 plus pi over 2. Then there was a last one that I'm sure you could figure out because it just replaces the trapezoid with the area of a triangle. And so I don't think I need to work that out for you. So what's really, really important for you to know? It is really, really important for you to know how these properties work. And it is really, really important for you to be able to find integrals using basic geometry. Okay? That's all for now.